Good morning, everyone. Myself, Assistant Professor Sandeep Shah, working at Technicals Group of Institute, Bhopal. And today we are going to start a new chapter of heat in mass transfer subject, and the chapter is heat exchanger. So this is the table of content in which we will study one by one. That is, the first is introduction of heat exchanger, then classification of heat exchanger, temperature difference distribution between inside a heat exchanger, and the next one is the expression of for log mean temperature difference, and another one is next chapter is heat exchanger effectiveness, and finally we will discuss about the effectiveness and TO relations. So dear student, we will first discuss about what is the heat exchanger and why we are using this heat exchanger. A heat exchanger is equipment built for efficient heat transfer from one medium to another. The medium may be separated by solid wall to prevent mixing, or they may be in direct contact also. So what are these applications of heat exchanger? Where we can see heat exchanger are widely used in space heating, refrigeration, air conditioning plants, chemical plants, petrochemical plants, petroleum refineries, natural gases processing, in sewage treatment. And examples, we can see some examples also. That is internal combustion engine, in which a circulating fluid flows through radiator coils and air flows past the coils, which cools the coolant and heats the incoming air. So next is the classification. So we know that there are wide range of classification of heat exchanger. The first we will differentiate or classified by using the flow configuration. So based on the flow configuration, we are having counter flow, parallel flow, cross flow, or hybrid. So this is one of the type of heat exchanger, that is the counter flow heat exchanger. Here we can see that a fluid flowing takes place to one heated fluid and another one is cold fluid flowing in opposite direction. So counter flow heat exchanger, in which two fluids flow parallel to each other but in opposite direction. So this is one of the type of heat exchanger. Now another one is the parallel flow heat exchanger. That is both the fluid will flow direction of both the cold and hot fluid flow will be in the same direction, and this is figure. Here we can see that the flowing hot fluid is flowing in the direction and cold fluid is also in the same direction. So this is the temperature distribution which takes place inside a heat exchanger. This is for parallel flow heat exchanger, this is for counter flow heat exchanger. So here we can see that there is a temperature drop of hot fluid and temperature rise in cold fluid. Here also temperature drop in the hot fluid and temperature rise in the cold fluid, but so the temperature profile for both parallel and counter flow is different. Another type of heat exchanger is the cross flow heat exchanger. Here we can see that a direction of fluid, hot and cold fluid, is perpendicular to each other. That is, here one fluid is flowing takes place and another is perpendicular direction. And next is the combined or hybrid form of heat exchanger. Here we can see that parallel, perpendicular, and for some instant it is parallel, for some instant it is perpendicular. So combined of both is known as hybrid flow. So the now next point of classification of heat exchanger is the by construction. Classification of heat exchanger by construction. Here heat exchanger may be categorized by recuperative and regenerative. So in case of recuperative heat exchanger, separate flow path for each fluid and fluid flow simultaneously through the exchanger, exchanging heat across wall, separating the flow path. Right, and another is regenerative heat exchanger, has a single flow path which the hot and cold fluids alternatively pass through. So the again recuperative type of heat exchanger may be indirect, direct, or special. And in case of regenerative, we are having static and dynamic. We will discuss one by one in subsequent slide. The first one is the cell and tube heat exchanger. Cell and tube heat exchanger consists of a series of tubes. One set of these tubes contains the fluid that must be either heated or cooled. The second fluid runs over the tubes that are being heated or cooled. A set of tubes is called the tube bundle and can be made up of several types of tubes, plain or longitudinally finned type. And so the cell and tube heat exchanger are typically used for high pressure applications. So this is the diagram, and we can see the diagram of cell and tube heat exchanger. Now the another one is the cell and coil heat exchanger. Here the cell and coil heat exchanger are constructed using circular layer of helical corrugated tube placed inside a light compact cell. Here this is one of the view or picture of cell and coil heat exchanger, and this is the sectional view. Or here we can see that cold water in and cold hot water out, and here stream flow boiler and steam return to boiler. Steam flowing through the boiler is getting condensed or cooled by using the cold water. So the cell and coil heat exchanger are constructed using circular layer of helically corrugated tubes. The fluid in each layer flows in the opposite direction to the layer surrounding it, placing a cross pattern. The corrugated tube produces a turbulent flow where the desired features of fluctuating velocities is achieved. The another one is the pipe in pipe heat exchanger. That is the double pipe heat exchanger is one of the simplest form of cell and tubular heat exchanger. Here just one pipe inside another larger pipe to make a unit very compact. The arrangement is made multiple times and continues serial and parallel flow. So we can see here in this diagram, that is pipe in pipe heat exchanger. Here flow here cell and cell side fluid flow in and here out of fluid is taking place, and here tube side fluid is in taking place, and cell side tube side fluid flow out. So this is the cell and tube type heat exchanger. And here in pipe, one it means one pipe is inside another pipe. The next one is the plate type heat exchanger. Here different plates are placed parallel to each other, and heat exchange takes place by passing the fluid through these plates. So now the next important term is the expression for log mean temperature difference, its characteristics and the rate of heat transfer. So we can calculate by using this formula, that is the expression for, that is we have to calculate the expression for the log mean temperature difference. Here heat Q is calculated by using UA, and temperature difference between inlet of hot and cold fluid and exit of hot and cold fluid. So this is the profile for parallel flow, and this is for counter flow. So logarithmic mean temperature is basically mean temperature difference between these two fluid at every section, because we know that the temperature difference between these two fluid at every point is different. So we have to consider a mean temperature which will be equivalent to the whole temperature difference. So we can calculate by using this formula, that is UA delta T outlet minus delta T inlet upon natural log delta T outlet upon delta T inlet. Delta T outlet is the temperature difference at exit, and inlet is the temperature difference between fluid in. So finally we will use this formula to calculate the logarithmic mean temperature difference. Where to use this formula? So we will use this LMTD for calculation of heat transfer rate. Here heat transfer cross flow heat exchanger, in case of cross flow heat exchanger, we can calculate the heat transfer rate. Q is equals to UAF LMTD. The here the overall heat transfer coefficient U is overall heat transfer coefficient, which will be calculated by using if we are having conduction convection combined mode of heat transfer, which is basically takes place inside a heat exchanger. So we will use this formula to calculate, to find out the convection the heat transfer through the heat exchanger by using 1 upon U is equal to 1 upon H inside plus L1 upon K1 plus L2 upon K2 plus 1 upon H outer. So this is the conduction convection combined for heat overall heat transfer coefficient. So now we will use this important term, that is heat exchanger effectiveness. So the effectiveness of heat exchanger defined as the ratio of actual heat transfer to the maximum possible heat transfer. So to find out the heat transfer rate, we will use this formula. Q equal to mH, here mass of hot fluid, Ch is the capacity of hot fluid, Th is the temperature difference between hot and cold fluid. So by using this formula, we can find out effectiveness epsilon equal to Q upon C mean delta in temperature difference. Here temperature difference is the Th minus Tc. Now the next term is very important, that is effectiveness NTU relation. So we will define new term, that is NTU. An useful parameter which also measure the efficiency of heat exchanger is the number of transfer unit. NTU defined as NTU equal to temperature change of one fluid upon LMTD. Thus for the hot fluid, NTU is given by this formula, temperature difference upon LMTD, and for cold fluid also the temperature difference upon LMTD. So the formula for counter flow and parallel flow of effectiveness will be in terms is a function of NTU and C min upon C max, and which will be given by this expression epsilon equal to 1 minus exponential or e power minus n1 plus r. So this is the example to understand this whole heat exchanger formula, or to apply the concept of this form. We can understand by solving this numerical problem.